Today, we look into domain and range of polynomial functions. So quickly, let's find the domain and range of the following functions. All these things here, all of them are all polynomial functions. So let's go ahead and find their domain and range. Yeah. So question 1 says f of x is equal to x. This question actually it's simple. Yeah. But the only simple part here is my domain. Yeah. Domain of this function called polynomial, it's simple. Remember that we said domain is where a function is defined, where a function can work. Like if it's fraction now, let's say I have x squared over x minus 1. It's a fraction now. This fraction can work at all points except where the under is 0. Except when the under here becomes equal to 0, and that is when x is equal to 1, because 1 minus 1 is 0. That is for fractions. But polynomials are not fractions. Polynomials will work everywhere, just like x. F of x being x. Anything you put as x is the answer. Anything that goes in as s becomes the answer. Like our input here becomes the output. Yeah. So with this, we can say that our domain dom f. Everything will work. Everything will work here. So our domain dom f is all real numbers, and the range of f is also all real numbers. In fact, to cut this class short, take note that just know that domain of anything polynomial, function, domain only, domain of every polynomial function is all real numbers, because everything will work. All the inputs must give you an answer. Every input will give you an output. For this reason, we now say that domain of all polynomial functions is all real numbers. Yeah, so domain here, in all of them is all real numbers. The difference here now is the range. The range is the possible output. Yeah, range is possible output. So the range varies. The range in 1 down to 7, they have different range, but the same domain, because they are all polynomials, and all polynomials have domain as all real numbers. Yeah, so number 2, this is number 1, or source number 1. Number 2, let's stop it here. Number 2 says f of x is equal to x power 6 plus x power 4 plus x power 2. So that was same time our domain dom f. What's the answer? All real numbers. If you don't want to write like this, you can go ahead and write this way, from minus infinity down to infinity. That's my domain for every polynomial function. Now the range R sub f will be equal to, now if you check this thing, The range, I know you are thinking the range is all real numbers. Range is the possible answers you can have. When you check this function, you will see that the powers of x are even. 6 is even, 4 is even, and 2 is also even. If you have even powers, complete even powers, then we can't have a negative output from this function. Anything you put inside here, be it -2, be it -5, be it a negative number, when they are being affected by the even powers, the even exponent, what happens? They become positive. With this, my range will not be all real numbers. My range will contain only positive real numbers, which starts from 0 down to infinity. Yeah, those that have learned interval notation will understand this thing here. Check our video on interval notation to understand this. That's it. Now, I am saying that here, if you check number 1, the power here is odd. When you have your polynomial to contain an odd power like 1, 3, 5, 7, 9, odd power, once you see one odd power in your polynomial, then the range becomes all real numbers, provided you are seeing an odd power. So in number 2, there was no odd power. All the powers are even. That's why my range starts from 0 down to infinity. At times, they could still give you an extension with a number. Let's say here now is +5. In this case, all this place now is 0 to infinity. Then +5 will now make your range to start from 5 instead of 0. Yes, that start from 5 down to infinity, because we are assuming here, we are taking that the least number, the minimum number that can enter here is 0. So when 0 enters, all this place becomes 0. So 0 plus 5 then starts from 5. So without this, your range is this. When I put a number here, like an extension, let me say -3, my range now becomes -3 down to infinity because of the extension to your even powers. Yeah. Let's forge ahead. Number 3. Question 3 says, without wasting time, let's just do it very fast. So, question 3 says 2x cubed minus 3x squared plus 4x plus 2. In number 3, I am citing even power. I am citing even power, and I'm also seeing odd power. And I am saying, whenever you cite an odd power in your polynomial, just know that the range is all real numbers. So, number 3, my range is going to be all real number for my range. Yes, my domain is the same for all of them, which is also all real numbers. So my domain is what? Domain here is what? All real numbers. Range, all real numbers. Yeah. So question 4, what happens? Question 4, I am also citing an odd power. And I am saying that whenever your polynomial function contains an odd power, we are safe to say that our domain is known already as all real numbers. So we are saying that whenever the function has an odd power, we are safe to say that the range is also all real number. Yeah. Now, number 4. The function says x squared. The power here is even. Our domain is all real numbers. Yes. How about our range? Because the power is even, our range here is going to be all positive real numbers. Because we can't have a negative answer, provided the powers are even all through. Alright. This is number 4. Number 5. Okay, number 6 now. G of t is equal to 12. Here, this one is different. Now, g of t equal to 12 means that my polynomial is a constant. We call this one a constant polynomial. So what's my domain? Domain of all polynomial is all real number. That's my domain, all real numbers. Now, what is my range? The range of a constant is that constant. Because all my output, if I put t as 5, I'll have 12. If I put t as 10, I'll still have 12. So the range of a constant is going to be the constant. Yes, because we define range as the possible output. So in this function, the only possible output is 12 and will always be 12. So my range here is 12. So domain range, domain range, domain range, domain range. Alright, so the last one, number 7. I know you can do it. Sam, can you? Yes. If you check here, I have even power. So first of all, let's write our domain first. Our domain here is what? All real numbers. Yes, that's our domain. Now our range. What's the range? If you check well, our power is even, but here we have an extension plus 5. So what do we do here? You know, here alone does not permit a negative output. Yes, I know you remember. So with this, my range here is going to start from 0 for only this, from 0 down to infinity. In case of when t is 0, we have 0 squared 0. But this plus 5 makes our function to always start from 5. Yeah. So with this, I'll have my range to be from 0? No, from 5 down to infinity. This will be my range. Close brackets, open brackets, showing that 5 is included. 5 itself is part of the range. I know you will learn something from this class. If you do, click the like button. Thank you.